Yeah, so I'm Shashank. So as Matthias was mentioning, so we're going to be talking about fair legal network analysis research software. That's quite a mouthful, so let's just get into that. And yeah, so I'm not going to get into the details of FAIR principles because he's already done that, and me not doing that is not going to focus on the reusable part of it. So I'm just going to mention that this is the focus point, and yeah, so just directly jumping into what is research software and or project. So that is basically that that is used to generate, process, or analyze results that you intend to appear in the application. So if you're a researcher, you often do this one-off approaches where you have a research objective in mind, and then you build something for it. And the problem with that is it only caters to that particular aspect of the research itself, and then it sort of just dies down, right? So, and then 5 years down the line or 2 years down the line, you try to go back into that. It kind of is very difficult to restart that because of dependencies and so on and so forth. So quite often in our own research work, what we have found is that every time we try to use something that's already there, it's quite impossible to set it up because it was built, let's say, 6 years ago, but it's still relevant today. But we can't really, fix that, and then we end up building it again. So we're basically reinventing the wheel. So that seems, unnecessary, right? So that's where I think, FAIR principles kick in. So then the question becomes, okay, we already have FAIR principles, but why not apply it directly on software? So the issue is that there are specific characteristics of a software that prevents us from simply saying, okay, let's take FAIR principles as is, that was done a couple of years ago, and then just pop it onto the software itself. So the key differences are the executability of it, right? So your software does a particular action, then it's not simply, let's say, as a dummy stuff rather. It's actually doing something. When you give an input, it produces an output, right? So in addition to which, it's also evolving on a continuous nature, right? So today, the software that you have developed caters to one particular type of input, but then tomorrow if the input changes, then you have to change your code to actually cater to that. So similarly, that leads to versioning of the system itself. So right now, when you apply FAIR principles to data, and then you actually look at, oh, isn't data also evolving? Which is true. So there is a thin line between data and software in terms of versioning over there. But still, when it comes to executability, I think there's a huge difference between data and your software. So what happens here is that for a software to be following or adhering to the FAIR principles, it needs to be well described. It needs to be inspectable. As Matthias was mentioning earlier, it needs to be documented, and it needs to be appropriately structured. When you look at research software, because of the lack of time and lack of, let's say, financial support, sometimes none of it is done. You just go there, write some code to do a particular task that caters to your objective, and then that's pretty much it. Right? So sometimes for a software to be executed, replicated, built upon, and combined, we need those points where it needs to be described, inspectable, documented, and appropriately structured. So then the question comes into, isn't free and open source software already fair? So if you're in the software domain and if you're a software engineer, so you already would have heard of something called free and open source software. The meaning of free and open source software is where the code is inspectable, the code is out there, and you can modify it in any way you want and then redistribute it. Sounds very similar to FAIR, but then the problem with FOSS is that it's only concerned about the source code and the license. It doesn't really cater to anything else. But then FAIR does not require data to be open either, right? So those I would say that is the stark difference between FOSS and FAIR principles. And I think, yeah, we're going to be doing sort of a switcheroo here, where I'm going to be handing it off to Gijs, and then I'm going to come back again. So
Yeah, we figured that this was the best time to explain a little bit about Case Law Explorer. So for the non-legal folks here, especially, what do we do? So this basically came from the idea that we were teaching a network analysis to our students, and it's actually quite intuitive to explain it, at least the application of it. We thought like if we can do that, why don't we create a bit of software so that people can just automatically apply network analysis to the law. I've learned a lot. I think I now also understand why a lot of these government IT projects often fail, or at least take longer than expected. I think there was a steep learning curve as to the issues here. Okay, so for the non-legal folks, this is basically what we've been doing for thousands of years. We read text, and we think about it hard, and we come up with intelligent things. And we've done that quite successfully because we still exist as lawyers. The digitalization that has taken place is mostly that what you see here, we now do that on the screen. So now we see text on the screen rather from just text in the books. What we often do in terms of legal reasoning is we look for some sort of consistency, and precedents are in that regard important. So a very simple rule. So let's say that the legislator at some point says it's not allowed to possess drugs, and then drugs are being defined as medicine or other substance with physiological effect when ingested or otherwise introduced into the body. So that definition obviously can come with some questions in terms of how to interpret that rule. Then you get a case, and then you have some pills, and then the question is this then drugs? Should somebody be prosecuted for this or not? Then there's a rule and says that falls under the definition or doesn't fall under the definition, and then somebody else says another case, and it's about alcohol, and then the question is alcohol drugs? And that case might cite the first case, and then somebody brings in a case on coffee, et cetera, et cetera. So at some point you have a bunch of cases that build on each other, that refer to each other. And in each iteration, the rule is specified. Sometimes there's deviations. There's things going. Okay, and with 3 cases, it's doable, so lawyers can comprehend this. But when we're talking about like thousands of cases, it becomes a little bit more difficult. So we call those precedents. So those are basically rules from prior cases that we use in subsequent cases in order to decide the facts at hand. And human analysis we can use that for a limited number of cases. But again, like if we're talking about hundreds or thousands or tens of thousands of cases, you cannot comprehend anymore how all those cases relate to one another and how the facts differ or coincide. So network analysis leverages the citation. So what you often see, like in the simple example, if one case cites another, if you have a bunch of cases doing that, at some point you can put that in a network, and you can kind of see like what are the most popular cases in the network. And all sorts of studies show that that popularity or centrality, as we call it in network analysis, kind of coincides with what you see in textbooks. And often, even with network analysis, it provides a better structure or more intuitive structure than what you would see in the textbooks. I even have bachelor students who have identified cases that are relevant that were not identified by any of the legal experts. So what we commonly use it for, there's many purposes of network analysis, but what we commonly use it for, also with students especially, but also in basic legal research, is what are the subtopics in a network? So what kind of subtopics can we distinguish in a certain network of precedents? And then also what are the central cases within the network as a whole or within the certain clusters that we identify? Again, there's many other questions you can pose, but it's kind of an idea. And this very well connects to traditional legal research, as I showed in the example, where you try to kind of test the coherence and consistency and try to pinpoint what these cases are about, and also what makes them different in terms of their facts and then in relation to the outcomes. Of course, the assumption is that courts cite for a reason. If they just randomly pick a decision out of the bucket and they cite it, then network analysis doesn't make sense. There's many reasons for citing a decision. Some courts cite it because everybody does it. There's certain cases that you just cite because everybody else does it. You can cite cases because you agree with the previous ruling, because you deviate from it, because you want to have a specification, or just because you want to give an overview. So there's different reasons, and not all of those reasons you can account for in network analysis. So every decision or every citation is treated as the same citation. So this is basically what we built. Shashank will talk a little bit more about the details, but this is kind of what it looks like. So this is an example on all Dutch Supreme Court cases. You see that by HR, which is Hoge Raad or Supreme Court. You see the year in the labels. And here you see a network, you see different colors. That means that they're about different clusters. There's clusters about the duty of care and to what extent an employer has duty of care towards the employee. There's clusters on causality, on the burden of evidence, on the statute of limitations, because often employer liability occurs because of like asbestos, for instance, which occurred in the 60s and the 70s, and a lot of years have passed. And there's a rule that after 30 years, you cannot claim anymore, with some exceptions. So here you see kind of the clusters. You see the node size increases depending on the incoming citations. In the software, you can manipulate that. You can use out degree or betweenness or relative in degree, all sorts of measures you can use to manipulate and visualize the network. On the right side, you see the metadata that we pull up from Rechtspraak.nl, the Dutch case law repository. If it has the metadata, we also have it. If it doesn't have the metadata, then of course we also cannot display that. We're also working on including European courts, so the Court of Justice of the European Union and the European Court of Human Rights, which publishes 100% of their cases. So then we can also connect Dutch cases to European cases. Then if we include other case law from other member states, then you can also make connections between, for instance, the Netherlands and case law in France for European decisions. And there's many possibilities that can be derived from that. Of course, you can extend that based on, let's say, similarity search and all sorts of things. That's something to do in the future. So this is kind of what it looks like. There's also all sorts of filters and magic you can do. I'm not going to show that. It's not that relevant. There's, of course, a search interface. You can look for EPLIs, which are the identifiers for cases. You can search for keywords, what people commonly do. Now, what's also interesting is you can search for articles. If you look for, let's say, a certain legal provision and you want to see what cases are attached to it, then you can use that. And you can also expand that by manipulating or varying in the degrees of separation. So you can create extra layers by not only looking in the citations in the search results, but also looking in the citations of the citations or the citations of the citations of the citations, and the other way, looking to at these citations to the search results. And so you can kind of manipulate the network. My prediction is if you put both at 5, you'll probably find every case that exists in the database. So that's kind of the background or the idea of the software. Of course, we try to make this fair, but I think one of the experiences also, it's not the top priority at some point, because you're funded and you need to report it and it needs to be done and it takes longer and you need more time and more people, etc. So that was a very interesting experience to see, like, okay, you want the most important thing, that you have a piece of like functioning software and how to make that fair in that regard. Fortunately, we have some experts who can do that. So Shashank, I'll get back to you.
Right, thank you. So, so you got the context of why we're building the application in the first place, right? So background to that. Then there comes the technicality of how do we actually go about achieving this. So for the Case Law Explorer application to work, so there are multiple components involved. So you have multiple sources at the beginning, which we need to extract. So all these sources are not all super friendly. It says, oh, here's the data. You can just do whatever you want. And, like, okay, thank you very much. And we're done. It's not really that. It's more like, oh, you have it in this format. And we don't really have any reasoning as to why it exists in that format in the first place, because they're like, you should just be glad we have this format, just use it. And we have that. And, it's, as Gijs was mentioning, we need to take in data from ECHR, which is the Human Rights, European Court of Human Rights, and the Court of Justice of the European Union as well. So each of these sources have a different format and require a different understanding of the data itself. So that means we need to build a type of parser, which focuses on extracting the data for that particular source. And then once we do that, that's not over yet, right? So we need to transform that data into a type of format or to the columns or attributes that we want, and then load it onto a database, right? Once that is done, then you have your front-end application, which was shown earlier, which looks into the data and says, okay, here's the citations and here's all of the links that you're looking at. Okay? So this is generally the view. So it's basically an ETL pipeline. So if you have a prior experience into data engineering, so you would say, oh, ETL is extract, transform, and load. So how does it work? You have multiple data sources. You do an API call, which is an application programming interface, which basically says, hey, can you give me a data in a certain format? And it says, here's your data. And you say, thank you very much. And you collect that data, and then you transform it into the structure that you want. And then you load it onto a database. If you don't want a database, you can just store it as a CSV file and do whatever you want. Right? So in our case, we are putting it into a database called DynamoDB, which is a database provided by Amazon. And then we have your Case Law Explorer front-end application, which was shown in the snippet, which peeks into the data and says, okay, thank you very much, shows you the applications shows you the results for one of your key searches. Then the question becomes, is your whole software fair for following fair principles? The answer to that is not yet, right? So, but then we are getting there. So when you look at the extraction part of it, I was telling you earlier that you have certain data sources which produce data in a certain way, and then we take that and say, okay, we're going to use it for this particular purpose. But then it's very easy to get into this horse vision and say, okay, I'm just going to do it as a one-off and cater to this particular solution and for this particular application, and that's it. So rather what we did was we said, let's sort of make it reusable, where we package the entire thing. So we say, when we are doing the extraction part of it, let's not do it as a one-off and just do it only for Case Law Explorer, but rather have this extraction as a separate project itself, where we'll package or we'll containerize this, so that anyone, irrespective of whether from Maastricht or from anywhere else in Netherlands or Europe itself, would be able to extract that, use that particular package for extraction of data from RexPark or ECHR or CJE, right? And then use that data however they want. Because the problem is the transformation and loading of the data is very use case specific, right? It's not generalizable. But then the extraction part of it is generalized. So that's the part we focused on. So then it brings to the question of which we didn't talk about earlier, is what are the principles of fair for research software? So I don't want to go into the complete details of each and every element of it, but usually if your software needs to be adhering to the research software fair principles, then it should have a unique identifier. So again, if you are a software engineer and if you use GitHub, you'll be like, hey, my repo has a unique name. Isn't that a unique identifier in itself? Well, not technically, right? So that doesn't give away much information. When we talk about unique identifier, it's like stored somewhere and you can just call that. But then you're referring to now a URL or a name, which is not really unique. And then does it have enough metadata? And then if the metadata adheres or contains all these identifiers and versions of the software it describes, is it in a searchable software registry and so on, right? So again, following on that, you have your accessibility. Can you access that by an identifier? Is the protocol that you're using for accessibility free and can it be universally implementable? Then the question becomes, does it allow for authentication and authorization procedure? Is the metadata even accessible when the software is, right? And then, is it interoperable, right? So interoperable can be defined in many ways. When you look at data, interoperable becomes, I have data here, can I use the data elsewhere? Right? But when it comes to software, you usually stick to the executability part of it. So if I, let's say, use Mac OS as my development platform, and I just say, oh, it works on my system, and then we switch the system, and then we're like, oh, it doesn't work. Right? So it doesn't work on Windows, it doesn't work on Linux. The question becomes why? Because, well, you haven't catered to the interoperability part of it. So that's where solutions like Docker or containerization comes into play. So that's what we try to do as well, right? So, or when we say we create a package in a language called Python, then we say, okay, this is not only executable on our platform, which is let's say Mac OS, but we also can run it on Windows and run it on Linux or elsewhere, right? So, and at the end of the day, in terms of reusability, is the software richly described with plurality of accurate and relevant attributes? Do they have independent, clear, and accessible usage licenses, which is a very important element of it? And then does it have enough provenance, which is agreed by the community? And does the document meet domain relevant community standards? If you're doing it in a programming language, there's always somebody who's defined, or a certain set of people have defined what the standards are for the programming language, and we make sure that we adhere to that. If not, then we sort of do code reviews where we ask students to follow those standards and make sure that we are doing well. So that leads to the question, how do we fare? That's a play of words, if you didn't recognize. Basically, in our own project, we evaluated how do we fare. And so because we put it only on GitHub, although it is findable on GitHub, it is not really, does not have a unique identifier yet. So when I looked into it, they sort of integrate Zenodo into their platform. So you can, if you have registered your account and software on Zenodo, then of course you can import that value onto GitHub itself. Does it have rich metadata? We're getting there. I think we have sufficient metadata, but we can do better. So we're in the progress of updating that. And then is it in a searchable software registry? Yes, it's on GitHub. So that's where most of the open source software are now. So you can easily search for it. Because we don't yet have a unique identifier, so we can't access it by that. So it's not fully accessible yet. All of the others where it's open, free, and universally implementable protocol or GitHub, yes. So they usually talk about HTTPS and stuff like that. So that's what it means. The answer to that is yes. And is the metadata accessible even when the software is? Yes, because you have uploaded certain information where it says, this is what the software does, this is why we're doing it, and so on and so forth. So that information is accessible. So even if the software doesn't work, we have enough metadata over there so that somebody can understand why we did what we did, what are the steps we follow to do it. So end of documentation provides that insight. In terms of interoperable, I think we fare extremely well over there, is because we have 3 check marks over there. So where we say we use a formal language and it's accessible, we make sure that the data that we're producing is machine readable and can be part of the data exchange. And so the software that we produce also use controlled vocabularies such that they follow FAIR principles. And then we make sure that all of the dependencies that we are using for doing our work are documented, and we provide links so that that exists. Right? In terms of reusability, if the last 3 points are tick marked, then the first point automatically also works. But because we don't have those detailed provenance with detailed agreement by the community, we sort of don't check mark on all of those points for the reusability aspect. Right. But then, generally speaking, I think for the last year, we've been doing relatively well in terms of producing FAIR software, at least in the backend part of it, which is the ETL part of it. We hope that in the coming months or years, we'll be able to do the same for the front end part of it, where we Dockerize the entire application, where anyone is not tied to a particular platform to run the application, but they can just run it locally as and how they wish. Right. So that's sort of our take on the software part of it. And I think here there are a couple of useful links on the application itself. We've deployed it on Amazon Web Services, so you'll be able to access the application over there. You can sign up, and then you'll be able to access the data. And of course, everything's on GitHub, and we have some documentation available as well. So yeah, I think that sort of sums up our presentation. We appreciate your attention. Thank you very much.
Want to learn more about the open science movement and FAIR? Find our next events below.